And then your x-intercept is going right here, 0.6, which is 3 over 5. Okay, there we go. So our function is going to pass through our x and y intercepts, and you're going to see that it's like this. Okay, does that make sense so far? So that's how you're going to draw this graph. Okay, so if you want to check, so I think a lot of students may want to know about this. So let's say, how do you know if your rational function, you're supposed to draw it here, and like if you're supposed to draw it here? Well, I think it's very kind of obvious that if you have an x and y intercept on this side, right, your function needs to be there, because that means you're going to pass through your x and y intercepts. But let's say, how do you know that you're graphing this part of your function over here as opposed to, over here? So if you have, let's say, -3, so pick any number that is before -1/2, so let's say -3. And if you try to plug in -3 in your function y is equal to 5x minus 3 over 2x plus 1, maybe we can do that. So we have 5 times -3 minus 3 over 2 times -3 plus 1. You're going to see that if you plug in -3, which is before -1/2, because you want to observe what happens to your function as you go from the left side of -1/2, right? What happens to your function here? So you can do a test run. So if you plug in -3 here, or any number, it could be -5, right? As long as it's before -1/2, you're going to see that your y value, if your x is -3, your y value is a positive number, which is 3.6. So that means if it's before -1/2 or the left of -1/2, your function needs to be positive. That's why you're drawing this up here. Does that make sense? So that tells you that you're having your function